A pleasant afternoon to everyone. We would like to appreciate the presence of our thesis advisor, Engineer Josephine Villamin, our dear panelists, Engineer Obatay Oquendo, Mr. Elcano, Engineer Aranas, Miss Chin, Engineer Mystica, Engineer Gagalang, and to all of the persons here in the meeting. Um, Allow me to introduce myself. I am Melchime Conde, together with my co-researchers, Joseph Allen Camacho and Jason Katimpa. And today, we would like to present our proposed research entitled Waste from Tire Rubber as an Alternative Fine Aggregate for Concrete Paving Blocks. Globally, an estimated 1 billion tires reach the end of their useful lives every year. In the Philippines, with almost 10 million registered vehicles, about 10 million end-of-life or waste tires are generated yearly. And due to improper waste management and regulation of our country, these used tires frequently blocking rivers and drainage system or inefficiently piled up in landfills, trapping hazardous gases like methane and providing breeding ground for disease-carrying mosquitoes. So, where do these used tires usually go? According to Beretson 2018, 49% of these tires are burned into fuel, releasing dark, thick smoke that contains cyanide, carbon monoxide, and sulfur dioxide, which pollutes air and ocean. 26% are ground into filler for asphalt and insulation. 11% are dumped into landfills. 7% are blended into civil engineering uses. And the other 7% are recycled into things like playground surfaces and tire swings. About this, the researchers want to develop the remaining 11% into something useful in the engineering purposes and to promote the use of waste tires into much eco-friendly and pollution-free purposes. In addition with this, according to El Gamal 2010, recycled waste tire rubber is an auspicious material in construction due to its lightweight, elasticity, energy absorption, sound, and heat insulating properties. Thus, the researchers will conduct a study focusing on substituting fine aggregates with rubber tire crowns. Throughout the study, the researchers will evaluate three classes of concrete mixture containing different sizes of rubber tire crowns to determine the mixture's first compressive strength, second flexural strength. And to discuss the objectives of the study, we have Mr. Camacho.
For the objectives of the study, the main aim of this study is to utilize waste scrum tire rubber as an alternative fine aggregate in making concrete paving blocks. Specifically, this research aims to Objective 1. We need to produce three classes of concrete mixtures with sizes 4.75 mm, 1.18 mm, and 0.3 mm of rubber tire crowns and obtain the mixture with the highest compressive strength. For Objective 2, we need to determine the engineering properties of concrete paving blocks infused with rubber tire crowns, such as unit weight, flexural strength, and water absorption. Lastly, Objective 3, we need to analyze if rubber crowns are feasible as an alternative fine aggregate for concrete paving blocks based on the results. To present the conceptual framework, we have Mr. Jason Katimba.
For conceptual framework, in phase 1, which is the input, is the materials and equipment that we're going to use in this study. The main materials in this study are the cement, rubber tire crumbs, coarse aggregates, and water. The equipment necessary for compressive strength is the compression testing machine, and for flexural strength is the flexural testing machine. The manual that we are going to use is the Testing Concrete from CS1 2010 manual. For the phase 2, which is the process, is the procedures in producing the three classes of concrete mixture using tire crumb sizes 4.75 mm, 1.18 mm, and 0.3 mm as an alternative aggregate. This procedure includes the proper measuring, mixing, molding, curing, and testing of each block. For phase 3, which is the data gathering, we're going to examine each specimen according to the CS1 2010 manual, comparing the compressive and flexural strength of the regular concrete block to the three classes of the tire crumb mixture, and evaluation of the test results. For phase 4, our output is the specimen of concrete paving block with rubber tire crumbs that completed the procedure correctly.
For the significance of the study, the results of the experimental research will be beneficial to the following group of people. First is the university. The research study will contribute new ideas regarding the different use of rubber tires in the field of construction. Also, it will contribute to the university's research and development program. Next, we have the faculty. Additional data and information that can be used by the teachers in class discussions. Students, this will provide the students with factual information about the altered use of rubber tires for construction. Next, we have the researchers. Through these studies, the researchers would be able to recognize if rubber tire crumbs are feasible to use in field of construction. And it will also help them to gain new knowledge and experiences. Next, lastly, we have future researchers. This study can be used by future researchers as a guide and source of information. This will help them to develop products using waste materials.
For the scope and limitations of the study, these are the extent to which the research area will be explored and the parameters within which the study will be operating. First, we will produce concrete blocks in three classes of concrete mixture with sizes 4.75 mm, 1.18 mm, and 0.3 mm, waste from tire rubber as fine aggregates, gravel as coarse aggregates, Portland cement as binder, and water. We will use the safest concrete grade, which is M15 with a ratio of 1:2:4, having 4 parts for gravel, 2 parts for rubber, and 1 parts for cement. Using a wooden concrete cube mold, the mixture will be molded into a 15 cm by 15 cm by 15 cm concrete cube to be submitted in compression test, and a 15 cm by 15 cm by 75 cm rectangular concrete block for flexural strength test. The primary concentration of the study is bounded only for the compressive and flexural strength of the concrete paving blocks. The concrete paving blocks will be used specifically for walkways.
For our literature review, the researchers chose the most important variable that we use in conducting this study, and those are the rubber tire crumbs, water absorption, compressive strength, and flexural strength. For tire rubber, based on the research of Ivana Barisi entitled Recycling Waste Rubber Tire in Road Construction, it has been discovered that adding crushed rubber to cement stabilizers decreases the pressures caused by material shrinkage. The water capillary absorption of rubberized cement-plated aggregates is also mentioned as a benefit, which is a desirable feature for more durable pavement foundation layers. According to Aglen, Agbilo, and Reyes study, which is entitled Concrete Mixture with Cramped Tire Rubber, the concrete mixture having 0.75 up to 10% of cramped tire rubber as a partial substitute for coarse aggregates passed the allowable compressive strength for lightweight concrete. For compressive strength, based on case study entitled Waste Tire Rubber Particle Modified by Gamma Radiation and Their Uses as Modifiers of Concrete, conducted by Barrera, Diaz, Rabanal, Gayare, Lopez, and Olivares, concrete's compressive strength value and those with waste tire rubber particles. Such qualities were investigated as far as the parameters: curing time, tire rubber particle size, particulate concentration. As per curing time, compressive strength increases as curing time increases. As per particulate concentration, compressive strength value gradually decreases when the particulate concentration increases. For flexural strength, based on the study entitled Ground Tire Rubber as a Component Material in Concrete Mixture for Paving Concrete, conducted by Richard Tuamasi-Bouquet, shows that as a percent weight of ground tire rubber in the mix grew, the flexural strength of the concrete declined. However, there were hints of improved toughness in ground tire rubber samples. For water absorption, based on Mahirier's study entitled Investigation of Mechanical and Durability Properties of Cement Mortar and Concrete with Varying Replacement Level of Cramped Rubber as Fine Aggregate, the addition of cramped rubber to concrete enhanced the ability of concrete cylinders to absorb water. According to his research, replacing 10% and 20% of cramped rubber in the mix enhanced the water absorption capacity by 5% and 8% respectively, as compared to the specimen 1 in his experiment without any rubber in the mix.
For the definition of terms, this section contains all the important terms used in the present study. We have compressive strength, characterized as the limit of concrete paving block to endure loads before failure. Next, we have concrete testing. Quality tests on concrete pavement blocks are performed as a part of quality control on concrete structures. Next, we have chrome rubber, recycled tires and tar material from vehicles. Trucks and different vehicles are worn out, damaged, or replaced. Next, CS1 2010 Manual, reference manual that sets out methods and procedures to be adopted for sampling and testing concrete both on-site and in laboratory. Next, curing, characterized as giving satisfactory moisture, temperature, and time to allow the cramped tire rubber concrete to accomplish the ideal properties for its intended use. Next, we have flexural strength. This pertains to the ability of concrete paving blocks to resist bending deflection when energy is applied to the structure. Next, moisture content, the quantity of water contained in concrete paving blocks. And lastly, we have sieve, a tool for sifting the chrome tire rubber to sort the particles according to the size of 4.75, 1.18, and 0.3 millimeters.
For the research design, the method that will be used by the researchers of the study is an experimental research method. The purpose of the experimental research strategy is to establish the existence of a causal relationship between the two variables. The experiment manipulates one variable, measures the second variable, and controls the other to achieve this goal.
For the data gathering, to obtain data, information, and method, the researchers will use a variety of sources, including existing research, books, a professional journal, newspaper, magazine, existing works, website links, government reports, and other publications. This will assist the researchers in conceptualizing and planning the study's completion.
For supplies and materials, this table lists all the supplies and materials required for the project study, along with their quantities and specifications. The researcher will use 80 kilograms of regular Portland cement, 300 kilograms of coarse aggregates, 120 kilograms of rubber tire crumbs, and 30 kilograms of water. Cement, coarse aggregates, fine aggregates, water, and chrome tire rubbers will be mixed in a 15 by 15 by 15 centimeters molder for the compression test, and 15 by 15 by 75 centimeter molder for the flexural test.
We have here the tools and equipments we use in making cramped tire rubber in compressive strength test, flexural strength test, unit weight, and water absorption. For cramped tire rubber, we will use chisel to remove the steel belt from the tires. The utility knife, it will be used to remove the tire's sidewall. The leather gloves, it will be used to protect the hands from sharp blades. The sieve with number 4, 16, 50, it will be used to sieve fine aggregates, which are the cramped tire rubbers, sizes 4.75 mm, 1.18 mm, and 0.3 3 mm. The scale, it will be used to measure the weight of the concrete mixture. And the shredding machine, it will be used to shred the tire rubber. For compressive strength test, we will use trowel to mix the ingredients that go into producing concrete cubes. The rectangular pan, it will be used where the mixture is getting mixed. And 15 centimeter by 15 centimeter by 15 centimeter cube mold made from plywood, it will be used to shape concrete blocks for compressive strength. The filler gauge, it will be used to check the spaces. The basin, it will be used to cure the concrete cubes for 14 and 28 days respectively. The concrete machine or the compression machine, it will be used to determine the concrete blocks compressive strength. And the steel rod, it will prevent the honeycomb or voids from forming in the concrete blocks by stamping the sides of the module. For flexural strength test, we will use 15 centimeter by 15 centimeter by 75 centimeter mold to shape the concrete blocks for flexural strength. The vibrating table, it will be used to aid the compaction of materials in molds. The steel rod, also used to prevent honeycomb or voids from forming in the concrete blocks by tamping the sides of the molder. The cloth, it will be used to wipe away the excess water on specimens and to clean the testing machine. The trowel, it will be used to mix the ingredients. The flexural testing machine, it will be used to determine the concrete blocks flexural strength. And the basin, it will be used to cure concrete blocks for 14 and 28 days respectively.
For determining the unit weight, we will use unit weight container to contain the sample for unit weight test. Steel rod is to use for compaction. Mallet, it will be used to tap the sides of the container for the unit weight test. Cloth, it will be used to wipe away the excess mixture. Strike of plate, it will be used to strike off the top surface of the container for unit weight. Trowel, it will be used to mix the ingredient. For water absorption, we will use cloth to wipe excess water on the surface of the specimen. Basin, to submerge concrete blocks underwater. Scale, it will be used to measure the mass of the specimen. Timer is to set the time for each specimen to dry. Ventilated oven, it will be used to dry the specimens. For our construction procedure. For the construction procedure, our first step is the production of rubber tire clamps with specific particle sizes of 4.75 mm, 1.18 mm, and 0.3 mm. Second step is to determine the unit weight based on ASTM C138, which is essential for weight calculation process. Third step is to determine the water absorption based on ASTM C140, which gives an idea of strength of the concrete paving block. Fourth step is to determine the flexural strength based on CS1 2010 manual. It is important because it measures the concrete paving ability to resist breaking when pressure is applied. Final step is the determination of compressive strength, also based on CS1 2010 manual, which is essential in this study because it will be the limit of the concrete paving blocks to endure loads before failure.
For the design calculation, the table shows the bulk density of each material that will be used in the concrete mixture, based on bulk density chart of annual bulks. Ordinary Portland cement has a bulk density of 1,362 kilograms per cubic meter, while gravel aggregates and rubber crumb aggregates have a bulk density of 1,762 and 352 kilograms per cubic meter, respectively. The data above is an approximate bulk density only. The researcher will use the bulk density method to calculate cement, fine aggregate, and coarse aggregate quantities. The proper mix proportion used in this study is 1:4 graded as M50.
We can see here the mixed proportion of concrete blocks. For concrete cubes, there are 3 mixtures with the same mixed proportion, but the only difference is the size of tire rubber crumbs used as fine aggregates replacement. 0.3 mm for mixture 1 and 4, 1.18 mm for mixture 2 and 5. Lastly, for 4.75 mm for mixture 3 and 6. In order for us to make one piece of concrete cube, we need 1.12 kilograms of cement, 5.79 kilograms of gravel as coarse aggregates, and 0.58 kilograms of tire rubber crumb as fine aggregates, and 0.62 kilograms of water. While in making one piece of rectangular concrete blocks, we need 5.59 kilograms of cement, 28.94 kilograms of gravel as coarse aggregates, 2.89 kilograms of tire rubber crumb as fine aggregates, and 3.08 kilograms of water.
For our construction time frame. Under the construction frame, this is the duration of our planning until the evaluation of the specimen. First week is the planning. Second week is the collection or the gathering of data. Third week is the preparation of materials as well as the cutting and shredding process of the tire rubber. Fourth week is still cutting and shredding, assuming that it will not be finished in 1 week. Fifth and sixth week is the construction of forms. Seventh week is the designing and analyzing of the specimen. Eighth week is the construction of product. Ninth and 10th week is the reconstruction and revisions. 11th week is the testing of the specimen for its compressive and flexural strength. And finally, the last week, which is the 12th week, is the evaluation from the data that the researchers gathered from the previous procedures.
For the cost of materials, the table presented cost of materials that will be used in the present study. The table indicates the precise and vivid use of materials for the study. This includes one piece of 4 feet by 8 feet plywood, which costs 435 pesos per piece, 3/4 inch of coarse aggregates amounting to 1 peso and 76 centavos per kilogram, 4.75, 1.18, and 0.3 millimeters of rubber tire crumbs for 5 pesos per kilogram, Portland cement costing 5 pesos and 25 centavos per kilogram, and water amounting to 0.3 centavos per kilogram. The data presented is only the approximate cost of each materials based on the data gathered, with the total cost of 1,787 pesos. Thank you for listening to our virtual presentation entitled Waste from Tire Rubber as an Alternative Fine Aggregate for Concrete Paving Blocks. And now, the room is open for any suggestions, questions, and clarifications. Again, I am Melchini Iconte.
I am Joseph Allen Camacho.
And I am Jason Katigba.
And that will be all. Thank you.
Yan, okay. So, thank you for the presentations of the group number 1.